I'm Kimberly Axe.
I'm Ashley Foster.
And I'm Allie Paola. Based off of averages from the Professional Bowlers Association, the expected average for men each year is 200 and 180 for women. When you're an avid league bowler, the conversation comes up that men have higher averages than women simply because they're men. So we decided to test this. I went on Facebook and posted a status so that all my bowling friends could comment their averages for us. I felt like this was a really good technique to use because it's non-invasive and it allowed people just to give their data whenever they felt like it. We wanted to do another test to compare two means, which we would have needed two sets of different data for, but people were really unwilling to respond with their other averages for sport leagues because those tend to be a lot lower. We did a test for independence to see if bowling average and gender were dependent on one another, and a linear regression test to see if there was any correlation between the two. The null hypothesis for our test for independence is bowling average and gender are independent of one another. Our alternative hypothesis is bowling average and gender are dependent of one another, and this is what we are claiming. The null hypothesis for our linear regression test were rho equals 0 for our null hypothesis, and the alternative hypothesis was rho does not equal 0, which is what we are claiming.
For both tests, we used SPSS. The first test we did was a test for independence. As Ali stated, the national bowling averages for men was 200 and for women was 180. And our data shows for the mean for men at 202 and women at 185. Our F test statistic was 1.239 and our p-value was 0.272. For our linear regression for correlation test, our scatter plot shows a close positive trend with one outlier of 26. Our second graph, which is a normal p plot for regression, was not a good test for our data because we had competitive bowlers which have scores that are closer together, whereas amateur bowlers would have scores that are more scattered. Our R was 0.233 and our p-value was 0.138.
In summary, we ended up not rejecting the hypothesis. There was not enough evidence to support the claim that bowling averages and gender were dependent on one another. We did question whether that could have something to do with our sample sizes. Again, because we had 28 men willing to answer the questions versus only 14 women. So that could have varied in a different sample if we had more women respond. We also wanted to address there was another test that if we had tried to have gotten two separate samples over time that we could have ran to compare that, and we did not get a response on that. So we couldn't compare gender on that. Our second test that we were able to run, where we compared rho equals 0 versus rho not equals 0, there did show a correlation. There was enough evidence to support the claim that there was a correlation between the average, bowling average, and gender. The R statistic was small at 2.33, but that is not 0. It was what we would consider a weak correlation, but still one that existed. And so that question still remains of, is gender playing a role in the average? And that's a possibility depending, and we couldn't quite read that out with this project. That's pretty much it, I think.